Welcome. Today, we're venturing into a region of the night sky that truly embodies cosmic extremes. You see, it's a canvas where ancient myths of sea monsters are painted right alongside the hard data of cutting-edge astrophysics. This is the constellation Cetus, a place of violent stars, quiet solar systems, and unimaginably massive singularities. All right, let's dive into this celestial abyss.
First off, Cetus is just immense. Spanning over 1,200 square degrees, it's the fourth largest constellation in our entire sky. So we're not talking about some minor group of stars here. This is a colossal territory, a true leviathan of the night.
Our exploration today is going to be a structured one. First, we'll establish Cetus's astrometric profile, get its basic stats down. Then, we'll enter its stellar laboratory to look at some of its most remarkable stars. After that, we'll peer into the intergalactic abyss beyond, connect all this science to the ancient myths, and finally, I'll give you a practical guide for observing this monster of the deep sky yourself.
So let's begin with the fundamentals. These are the celestial vitals, the data that defines the constellation's presence and its relationship to us, right here, as observers on Earth.
You know, one of the most remarkable things about Cetus is its global accessibility. You can see it from 70 degrees north all the way down to nearly 80 degrees south. It's a truly cosmopolitan constellation. For the best views, you'll want to look in October and November as it climbs to its highest point at midnight, revealing its 170 naked-eye stars just below Pisces and Aries.
All right, now let's move from the big picture into the astrophysical heart of Cetus. This constellation is like a natural laboratory in the sky, and it's home to some of the most scientifically important star systems that we know of.
And this slide just brilliantly illustrates the constellation's theme of contrasts. On one hand, you have Mira, Omicron Ceti. It's an unstable, dying red giant. And on the other, you have Tau Ceti, a stable, sun-like yellow dwarf, really in the prime of its life. These two stars, neighbors in our sky, represent the violent end and the quiet middle of a star's evolutionary journey.
Now, the crucial point here is that Mira gave us an entirely new class of star. A long-period variable is a star that literally breathes. As this red giant pulsates, its whole diameter expands and contracts, causing its brightness to cycle dramatically. Mira can shine as brightly as the stars in the Big Dipper and then, over months, fade away until it's completely invisible to the naked eye.
Then, in 2007, the Galactic's ultraviolet telescope revealed something just astonishing. As Mira hurtles through interstellar space, it's shedding these vast amounts of its outer layers. And this creates a colossal tail of gas and dust that stretches for 13 light-years. Try to imagine a comet's tail, but on a stellar scale. It's a visual record of the star's slow death written right across the galaxy.
So now let's turn to Mira's quiet neighbor, Tau Ceti. It's just under 12 light-years away, and it's a near-perfect twin of our own Sun. This similarity is exactly what made it one of the very first targets for Project Ozma, the pioneering search for extraterrestrial intelligence. And today, we know it hosts at least 5 planets, with 2 tantalizingly close to the habitable zone. That makes it a key system for future study.
The third star in our laboratory is UV Ceti, a system that represents stellar violence of a completely different kind. It's actually the prototype for what we call flare stars. These are usually dim red dwarfs, but their powerful magnetic fields can suddenly reconnect, unleashing these tremendous bursts of energy from their coronas.
And the energy release is just staggering. In a matter of minutes, sometimes even seconds, a flare star like UV Ceti can increase its brightness by 100-fold. It's like an eruption of magnetic fury that really showcases the unpredictable and violent nature of some of the universe's most common stars.
Okay, so having examined the stars of our own galactic neighborhood, we're now going to shift our focus. We're going to peer past them into the true deep space contained within Cetus's boundaries, where entire galaxies and, well, gravitational monsters reside.
This is really the question that drives deep sky astronomy. The stars we've been talking about are just the foreground. Behind them lies an abyss filled with objects on a scale that just challenges comprehension. So, let's go deeper. And the first object we encounter out there is Messier 77. This galaxy is the prototype for an entire class known as Seyfert galaxies. The key feature is an intensely luminous core, what we call an active galactic nucleus. This is the visual signature of a supermassive black hole just furiously consuming surrounding gas and dust, unleashing torrents of energy. And Cetus hosts the defining example.
But even the black hole in Messier 77, it pales in comparison to what lies within the Abell 85 galaxy cluster, which is also located in Cetus. Here, we find one of the most massive black holes ever discovered, the ultramassive black hole at the heart of the galaxy, Homburg 15A.
The critical data point here is its mass, an estimated 40 billion times the mass of our Sun. Just let that number sink in for a moment. This isn't just a stellar remnant, it is a gravitational object of galactic proportions, a true singularity that has consumed the mass of billions of stars. To even try to visualize this, think about its event horizon, the point of no return. The diameter of Homburg 15A's event horizon is so vast that it would comfortably swallow the orbits of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Our entire solar system would be just a small morsel for this cosmic leviathan.
From the furthest reaches of quantifiable physics, we're now going to pivot back to human history. How did our ancestors, without telescopes or spectrographs, look up and interpret this very same patch of sky? What stories did they see written in these stars?
Well, the identity of this celestial creature has evolved dramatically over time. For the Mesopotamians, this area was Tiamat, the dragon of primordial chaos. The Greeks, through Ptolemy, codified it as Cetus, the sea monster. By the medieval period, you see star charts depicting it as this bizarre chimera, a hybrid monster reflecting the era's fascination with the grotesque and fantastical.
And this all leads us to the grand celestial drama. So Queen Cassiopeia boasts about her beauty, which enrages the gods. In retribution, Poseidon sends the sea monster Cetus to ravage her kingdom. The only solution? Sacrifice her daughter, Andromeda. But just as the monster emerges from the depths, the hero Perseus arrives. He uses the severed head of Medusa to turn the beast to stone, saving the princess and the kingdom. It's a full-on soap opera, played out by the constellations themselves.
So we've journeyed through the science and the mythology of Cetus. Let's wrap this up with a practical guide so you can step outside and locate the celestial monster for yourself.
Locating Cetus is pretty straightforward. If you're in the northern hemisphere, find the V shape of Taurus and the famous Pleiades star cluster. Then just move west from there, or simply look directly below the little circlet of stars in Pisces. Your target is a distinct pentagon of stars that forms the monster's head, with a trail of stars forming its body and tail.
And what can you actually see? Well, with just the naked eye, the head and the bright tail star are visible. With a good pair of binoculars, you've got a shot at spotting the variable star Mira when it's near its peak brightness. And if you have a modest telescope, you can hunt from Messier 77. It'll look like a faint, fuzzy patch with that telltale bright nucleus, the signature of its active black hole.
In the end, this really is the profound duality of Cetus. It is both a monster from our ancient, fearful imagination and a laboratory revealing the fundamental workings of the universe. To look at this constellation is to see the story of humanity and the story of the cosmos intertwined. It is a reminder that in every patch of night sky, there are depths waiting to be explored.